So now let's look at the nutritional needs of soil and how we determine what a soil needs for any type of crop or grass that you might be growing to graze. So different ways that we can do that, and there are a lot of different ways, but one of my two favorites that we do, because it's very to the point, is soil testing and then tissue testing. So soil testing, I'm going to teach you how to do this. You're going to take a soil probe and go out to, depending on the size of the field, you're going to collect anywhere from 20 to 40 different soil tests or soil probe tests, and you'll put it in a little bag and take it to your local extension agent, or you can send it off to a private lab as well. They will analyze it. Depending on the test that you pay for, it will tell you anything from the NP and K that is in that soil, and then it will give you recommendations on what you need to fertilize. So anything and it will even tell you your soil texture as well. So that is very important. Some people will do that every 3 years, and some will do it more than that. So we do it about every year, at least once every year on every field, and sometimes two, depending on what kind of crop we're following after our summer crops. Tissue testing, kind of the same thing. You're going to take about 20 to 40 different tissue samples of the plant that you have in that field, but many different places throughout that field. And so that's just going to analyze and identify the different elements that are in that tissue test, that are in that leaf. And a tissue test is just taking the leaf, the tissue is the leaf. So you're just going to take that leaf and be able to analyze all of the nutrients that are present in that leaf, but you will, if there are any deficiencies, you'll be able to find them as well. So fertilizers. So we have two big, broad types of fertilizers. We have non-organic and then organic. So this is just material that we put on that soil and or that crop to promote the plant growth that we'll have. And this will contain specific nutrients for that plant, or in some cases can contain many different nutrients for that plant. Lime is a very common type of fertilizer that we have, and that's applied to soil that has a lower acidity, and that will affect that nutrient availability a little bit more. And again, fertilizers can be organic and or inorganic. So let's talk about organic fertilizers. So again, organic fertilizers have to be regulated by the USDA. So any organic fertilizer has to have, if it's going to be considered USDA organic, it has to go through the USDA to make sure that it's meeting all the rules and regulations for that. So organic fertilizers is defined as anything deriving from a living matter that will contain a carbon element. And so this comes from anything from green manures, so anything that we plant. If we plant a cheap hay grazer in a field and then disc it under before it matures, that would be considered a green manure. Composts, manures, anything of that matter would be considered an organic fertilizer. Also, we'll have to decompose depending on that carbon to nitrogen ratio and how it's interacting. So a lot of science goes into defining organic fertilizers, and different companies and businesses in the ag world will try to get it USDA certified so that they can stamp that sticker on there and kind of a marketing thing, but kind of one of those aspects of being proud of what your company or business is, and getting the USDA on board with you is really important. Inorganic fertilizers is just man-made or synthetic, can be mined as well. They have the nutrients that are more concentrated, so it might take a little less for those nutrients to be applied. We look at micro and macro fertilizers, and a lot of the commercial nitrogen fertilizers that we have are through the Haber-Bosch process, which we'll talk a little bit more in class this week. But a lot of farmers and ranchers, when they're spreading nitrogen, have a little bit more availability or a little bit more choosing of what kind of commercial nitrogen that they want to apply. So it's kind of whatever they're choosing, and we'll get to look at a couple of those ways this week in class. So this is anhydrous ammonia. You might remember, if you do remember, about 15, 20 years ago, we discovered that there can be some intense drugs made out of anhydrous ammonia. So after that came to, we started seeing a lot more rules and regulations with anhydrous and how we could spread it or spray it and how we can use it. So we'll talk about that more in class. This is just injecting that anhydrous into the soil, and again, something that is now very regulated, and before 15, 20 years ago, it wasn't as regulated as it is today. So this is a fertilizer bag that you might see at a Tractor Supply or an Ace or even a co-op. So you see 3 numbers on there, and you see a 20, 10, and a 5 on the top of that bag or the grade. So that means that the 20 is considered the N number, the nitrogen number. The 10 is considered the phosphorus number, and the 5 is considered the potash number. So below there, the analysis, you can see that there are 4 numbers there. Total nitrogen percentage is 20, phosphoric acid is 10, available potash is 5%, and then the iron is 0.5%. So that's the analysis of that label, or of that fertilizer. And we'll talk in class how that has to really interact with the way, with the soil and the way that it's going to enhance that plant growth as well. And then we're going to look at different marketing aspects that ag consumers and then those ag companies really try to make you look at. So how do we apply fertilizer? So let's say I get my soil test back, or I get my tissue test back, and I know what I need to put on that soil to make sure that that plant growth, or that soil's getting what it needs for that plant growth to happen. So here are different ways that we apply fertilizer. We see broadcasting, that's just applying to that soil surface. Injecting, like we saw in that anhydrous image, it's just injecting below the surface soil. So again, it's not injecting above, it'll be injected below. Banding, so it's going to apply near the crop seed, where the crop seed is planting. Side dressing, it's going to alongside an emerged crop, so that crop has already popped through the soil. Fertigation, that is in an irrigated system. You put that fertilizer right through it, so it becomes a soluble fertilizer, and then is put onto the soil. So now we look at the application or the placement, and this is just the slide before how we put those in. So here's an injected fertilizer there in the middle. It's showing you how it's injected into the fertilizer. Broadcast fertilizer just right on top. Plowed down fertilizer, obviously plowed down into that B layer. Banded fertilizer, side dressing, top dressing. Top dressing is just thrown on top of the leaves at a certain growth or development point. Here are some good nutrient management practices that are really important for the success of producers. So the first one is just testing that soil on a regular basis, and that is very, very vital, and it takes a very, very small amount of energy to do, and it's tax deductible. So what you spend on that soil test, you can actually write off on your taxes, and that soil scientist is going to give you recommendations of what type of fertilizer you need to use, what you need to throw down percentage-wise, and it's a really good management practice. Testing manure before you buy it. So let's say you want to throw down chicken litter on a cornfield before you plant it as a manure. Making sure that farmer that manure is coming from has it tested, and you're not getting too much or too little of a nutrient that you need. Timing that fertilizer is always important, but it's really hard to do that with Mother Nature sometimes. And then practicing soil conservation. So always having that good aspect of how soil conservation should be worldwide, and always having that goal in the back of your mind of how to pass this on to the next generation, and then incorporating different green manures and perennials into rotation, and we'll talk about that more in class this week as well. So soil degradation, we talked a little bit about this the last chapter. These are just some fast facts that I really want you to understand and kind of grasp. But erosion is just that really fast loss of soil through either wind or water. So per year, okay, this is per year, water erosion, there's a loss of 3 tons per acre per year, okay? Wind erosion is about 2 tons per acre per year. So what is it removing first? It's not removing the sea layer, it's not removing bedrock, it's actually removing the O layer, which is very, very vital to nutrient management. So that is something to kind of put into your head and look at the big picture of how much soil is actually being lost because of water erosion and then wind erosion. So this is a cool graphic. We're going to look at it more in class, but I just want you to see some similarities within these two graphics of the United States. So first look at the top. We see wind erosion. So first look at the West Coast and then look at the East Coast. Okay, so as you go from the West Coast to the East Coast, what's happening to those numbers? The East Coast, there's barely nothing with wind, but the West Coast, in the middle of more of the western part of the United States, we have some big numbers, okay? So Colorado, 11.3, New Mexico, 13.8, Texas, 7.9, Oklahoma, 1.5, but then there's Arkansas and there's a 0. So what's the difference? What do you think the difference is? Now look below, you're going to see that water erosion. Now look again from the western part of the United States to the eastern part of the United States. What are those numbers seeing? How are you seeing those numbers? We see more of a growth from the western part to the eastern part. So eastern part's going to have more water erosion. Western part of the United States will have more wind erosion. So this is an annual wind and water erosion. Isn't that crazy? It's crazy to think that, one part of the United States will have more wind and one part will have more water. But if you think of the way, for example, if you think of the way storms form, they're going to form on our East Coast and they're going to push through and really build that intensity throughout their track through the United States. So you can see why there's a little bit more water erosion than in the East Coast than there is in the West Coast. So how do we reduce that soil loss? What can you and I do to make sure that we're not giving to those 3 tons per acre per year and 2 tons per acre per year? Maintaining some sort of vegetation cover, whether that's a cover crop, whether that's a cheap hay grazer, whatever that is, making sure that there's something in that soil to cover it. And then leaving some sort of soil residue, leaving something in that soil that would be considered a residue. So growing wheat winter wheat is a good example of this. So we're going to leave that, we can leave that wheat straw, we can leave that wheat stubble into that soil when we harvest it in June, and then just drill soybeans right into it. Or plant soybeans right into it, maintaining a high organic matter, which again is something that's built up year after year, and then using some different strategies like crop rotation, wind breaks, strip cropping, grassways. Those are all very important as well.